afternoon to welcome you to this, the 54th Institution of Electrical Engineers Faraday Lecture. I should perhaps begin by apologising for the slight delay, but this is the first presentation of the lecture, and the STC wanted to make sure that all of the audience could get a proper view. I think you'll see the reason for that in a few moments. Michael Faraday was one of the great pioneers of electrical engineering last century, and each year the institution organises a lecture in his memory. These lectures are intended to illustrate developments in electrical engineering, and we're fortunate that this year STC have taken up the opportunity to present the lecture as part of their centenary celebrations, which will be taking place this session. The lecture, as you'll see, deals with the revolution that is being produced by the application of light as a medium for telecommunications. In introducing the lecture, I should like to thank the team from STC who have prepared their presentation for you, and to wish them success with the tour on which they'll be going around the country after the presentations in Edinburgh here today. Your lecturer this afternoon is Saunders, who is normally working with Exacta circuits in Selkirk here, fairly locally. And so with that introduction, I shall leave you with the 54th Faraday lecture and your lecturer, Saunders.
Out of earshot, one waves, the other waves back, uncertain of the message. Over longer distances, we need assistance. Men have long known that light can be seen from afar. They lit a chain of beacons to signal the fall of Troy. They were still at it 3,000 years later to signal the approach of the Spanish Armada. They even did it again to signal the wedding of Charles and Diana. But most of us watch that on television, and the fireworks too. Herodotus, in 480 BC, reported that the soldiers in the Persian wars used their shields to reflect the light and flash a warning across the sky. It is a technique still employed. A heliograph reflects sunlight in flashes off a movable mirror, like this. But all these methods have their limitations. We must know when to expect the signal and where to look for it. Because light travels in a straight line, you need to see the source. Even then, poor weather can make it hard to pick out the message. Both sender and recipient must understand the same code. But most importantly, none of these devices takes anything like full advantage of the swift speed of light, for they are restricted by the slow speed of man, who can neither send nor receive the information quickly enough. For centuries, communication marked time. Michael Faraday changed all that. His discovery of the laws of electromagnetic induction made it possible to generate electricity continuously, and men found ways to use electricity to carry signals over long distances. Sender and receiver no longer had to be within each other's sight. Faraday's work led directly to the development of telecommunications.
We have a sense of pain and burden, such as the world never felt before.
Of modern time, I am enabled this Christmas Day to speak to all my people throughout the Empire.
This is the BBC television station at Alexandra Palace. At 3 o'clock this afternoon, the television service was opened by the First Master General.
This country is at war.
Now, as General MacArthur said after the surrender ceremony, the entire world lies quietly at peace.
Not below Cambridge, I think Cambridge way. I don't know there. I'll go off to Cambridge. Next, hello. He died 35 minutes after the shooting.
Liftoff. We have a liftoff.
It's one small step for man, one giant leap for mankind.
But all this is not enough. Today's worldwide communications network has its limitations, for we need to send more information, more quickly, and more cheaply. Now, 150 years after Michael Faraday's discoveries, we are turning once again to light to bring us all together. To see why and how, we need to understand light and the way a modern communication system works. James Clerk Maxwell, the Scottish physicist who took up Faraday's work, demonstrated after years of experiment that electromagnetic forces travel in a similar pattern to light and at a similar speed. By varying its frequency. We can do this far faster and so send much more information. And rather than turn light to electricity and back again to light, we shall regenerate such a signal optically. To make full use of this capacity, we must switch the light as well. We can move the fibre, directing the beam to the right outlet. Deflect the light itself with a prism or mirror. Or best of all, pass it through a material that will bend it with precise control in a voltage amplifier, thousands of millions of times a second. Photons, not electrons, will connect us. When we master these techniques, we shall have a resource limited only by our own imagination. And our imagination is already at work. We know that we shall not just talk on the phone, but talk and see each other too. Send pictures. Give doctors notes on patients miles from home. The latest information on their subject. We'll do this too for engineers, for scientists, lawyers, architects and artists, farmers and financiers, for students too. Send data as far and as fast as we wish. Run dangerous processes from a distance. We'll shop from home if we like. Order our goods. Pay for them. Book our holiday. Or an evening out. Check our balance in the bank. Vote on vital issues. Receive our newspapers electronically and our mail. We'll work, perhaps, from home. We shall have as many television channels as there are human interests. the disadvantages of distance will diminish, and those of time. We will communicate anything to anyone, anywhere, with all the speed of light. But stop. And think for a moment what this might mean. Every activity in which we use information will be simpler, swifter, shorter. We know new technology brings its problems as well as its advantages. Jobs will change. What we call work, what we call leisure. But this new technology will bring us a greater freedom too. Help us solve some of our problems. And there is more to it than this. We built our way of life on our ability to acquire information and to communicate it. And when we have more knowledge, information understood, many things may change. The way we do things, certainly. And we ourselves, perhaps. But we shall be the masters of this new technology, not its servants. Michael Faraday would be proud of us.